Good morning and happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, today we're going to go on in chapter 10 and take a look at section 10.2. We'll spend today on it as well as Monday. So what we're going to be looking at today is something called the quadratic formula. And basically what happens if you take the following, ax squared, looks like a 9, let's make that into an ax squared, plus bx plus c equals 0. And you follow the steps in completing the square. So you divide everybody by a, then you move the constant to the right, then you take the coefficient of x, cut it in half, square it, add it to both sides, you get a perfect square on one side and a constant on the other, take the square root of both sides, yada, 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 yada. Eventually, you end up with the following. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And this is called the quadratic formula. This is a formula that you want and need to memorize. It is a way of solving second-degree equations without factoring. Yeah, so anyway, I'm going to start by taking a fairly easy example and we'll solve it by factoring, and then we'll use the quadratic formula just to show that, yes, it does work. So let's take the following second-degree equation. X squared plus 3x plus 2 equals 0. To factor this, it's a trinomial in standard form with a leading coefficient of a 1. There's no greatest common factor. So we'd have an x and an x, a product that's 2, and a sum that's 3. So the numbers are 2 and 1, so plus 2 and plus 1, okay? So if x plus 2 equals 0 and x plus 1 equals 0, solving the one on the left, we'd get x equals negative 2. Solving the one on the right, we get x equals negative 1. So this equation has these two solutions, all right? Now we're going to go back and we're going to solve it using the quadratic formula. For this particular example, using the quadratic formula is actually more work, but I just wanted to use an example to show that, yes, we get the same results. So let's take x squared plus 3x plus 2 equals 0. Note that it is in standard form, okay? So a is 1, b is 3, and c is 2. The formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So what we're going to do now, so we're going to make this a little bit shorter, okay, is plug these numbers in to the formula, all right? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now it's a matter of simplifying. X equals negative 3 plus or minus the square root of 3 squared is 9, minus 4 times 1 times 2 is 9 minus 8, all over 2. X equals negative 3 plus or minus the square root of 9 minus 8 is 1, all over 2. X equals negative 3 plus or minus, well, the square root of 1 is 1, all over 2. So x equals negative 3 plus 1 over 2, negative 3 minus 1 over 2. Well, negative 3 plus 1 would be negative 2 over 2 is negative 1. And negative 3 minus 1 over 2 is negative 4 over 2, which is negative 2. So x equals -1, x equals -2. Note, those are the same two solutions we got factoring. Now, again, factoring this problem was much easier than using the quadratic formula. But there are some problems that it's tough to factor, or there are even some that don't factor because they don't have integer factors, or they use radicals in them, and we can solve those using the quadratic formula. But so we're going to be using this formula. All right. Let's take a look at another example. 6x squared minus x minus 1 equals 0. This is in standard form, descending powers of the variable set equal to 0. So a is 6, b is -1, and c is -1. Note, if we go back to chapter 6, when I talked about factoring by grouping the ABCPS method, this is the same a, b, and c that you would identify there. Anyway, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I suggest that you try to write the formula from memory each time you do a problem. That will help you to memorize it. So we've got x equals -b plus or minus the square root of b, the quantity squared, minus 4 times a times c all over 2a. Simplifying, x equals, subtracting a negative is like adding a positive. So we get 1 plus or minus the square root of -1, the quantity squared would be a +1. And then minus 4 times 6 times -1 would all become plus 24 all over 2 times 6 is 12. X equals 1 plus or minus the square root of 1 plus 24 is 25 all over 12. X equals 1 plus or minus the square root of 25 is 5 all over 12. So we've got x equals 1 plus 5 over 12, which is 6 over 12 or 1/2. X equals 1 minus 5 over 12, which is -4 over 12 or -1/3. So x equals 1/2, x equals -1/3 would be your two solutions. Any questions about this? Are we good to go on to another example? I'll take that as a yes. All right. How about this one? X squared minus 18x plus 81 equals 0. A is 1, B is -18, C is 81. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Subtracting a negative is like adding a positive. X equals 18 plus or minus the square root of, if we take -18 times -18, we get positive 324, minus 4 times 1 would be -4 times 81 is minus 324 all over 2. So x equals 18 plus or minus the square root of 0 all over 2. X equals 18 plus or minus 0 over 2. Well, 18 plus 0 is still 0. 18 plus 0 is 18. 18 minus 0 is 18. So basically you get this, which is 9. But this is a repeated solution. okay, because we get the same solution twice. Notice if we factored this, it would be a perfect square trinomial. Anyway, all right. Any questions so far? Okay, I'll just keep plowing ahead. T squared equals t plus 4. So here we need to put this equation in standard form. As with factoring, it works out nicer if my leading coefficient is positive. So I'm going to subtract t and subtract 4 from both sides of the equation. So now I get that. So a is 1, b is -1, and c is -4. Now, actually, it isn't x equals -b plus or minus the square root of b squared minus 4ac all over 2a. It's t equals -b plus or minus the square root of b squared minus 4ac all over 2a, because we're solving for t. So t equals, subtracting a negative is like adding a positive, 1 plus or minus the square root of -1 times -1 is +1. And then -4 times 1 is -4 times -4 is +16 all over 2. So t equals 1 plus or minus the square root of 17 over 2. Now, 17 or the square root of 17 is irrational. I can't simplify that at all. So my two solutions are t equals 1 plus the square root of 17 over 2, and t equals 1 minus the square root of 17 over 2. Now, as I mentioned, WebAssign doesn't like the plus or minus notation for you to enter it, so you list them as separate solutions. It also asks us to approximate the solutions to the nearest 100. Okay. Now, what we're going to do, let's take this first one. On my calculator, I'm going to have a left-hand parenthesis, 1 plus the square root of, and then there's going to be a parentheses around the radical, and then another set or another closing parenthesis for the entire numerator. Okay, so again, I've got a set of parentheses. The ones in red are around the entire numerator. The smaller set in black is the radicand. Okay, but I need that set around the whole thing so that I'm dividing all of it by 2. All right, so on the calculator, left parentheses 1 plus square root of 17, close up the radical, put a second parenthesis to close up the whole thing, divided by 2 equals, and I get 2.561, etc. It said to round to the nearest hundredth, which would be there. The 1 would round down, so 2.56. That would be the first solution. Then let's deal with this. So that's going to be 1 minus the square root of 17. Again, closing up the whole thing, divided by 2 equals. And I get for this negative 1.561. So that would become negative 1.56 because the 1 would round down. Okay. Any questions about that? Anything to do with the quadratic formula or using the calculator, the parentheses? Any questions there? All right, we'll continue.
Yep, I think I'm good.
If you're good, all right, excellent. Okay. So let's see here. Let's do this one. 4, I'm going to use black. 4w squared plus 1 equals negative 6w. So again, I want to put this thing in standard form. So I'm going to add 6w to both sides of the equation. So I get 4w squared plus 6w plus 1 equals 0. A is 4, B is 6, C is 1. So W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Simplifying, W equals negative 6 plus or minus the square root of 36 minus 16. 6 squared is 36 minus 4 times 4 is minus 16 times 1 is still minus 16. All over 2 times 4, which is 8. W equals negative 6 plus or minus the square root of 20 all over 8. Okay. Now, I can take the square root of 20 and write it as 2 square roots of 5. Okay. So this becomes W equals negative 6 plus or minus 2 square roots of 5 all over 8. However, look at this fraction. Notice that the negative 6, the 2, and the 8 are all even, so I could reduce this down. And what I'm going to do is this. They all share a common factor of a 2. So W equals 2 times negative 3 plus or minus the square root of 5 over 2 times 4. Now, what did I do here? I factored a 2 out of that and out of that, okay? And then I factored a 2 out of the denominator. And the reason I did that was so that I could reduce it down to that. Okay. Now, I'm going to erase this. So I'm going to use that room. So W equals negative 3 plus the square root of 5 all over 4. W equals negative 3 minus the square root of 5 all over 4. Again, I'm going to put them in my calculator to get a decimal approximation. And again, I'm going to need parentheses around the entire numerator as well as around the radicand, that is the 5. So left-hand parentheses, negative 3 plus the square root of 5, close up the radical, close up the entire numerator, divided by 4, and I get negative 0.190. So the 0 would round down, negative 0.19 would be the first answer. Then the second one, left-hand parentheses, negative 3 minus the square root of 5, close it up, close up the whole thing with another set, or another right-hand parenthesis divided by 4. We get negative 1.309. So the 9 would round up, negative 1.31 would be the other solution. Let's see here. So we've got this and this. Those are our two solutions approximately, and these are the two exact solutions. Any questions on that example? All right, let's take a look at some things we can do to the second degree or quadratic equation before we put it into the formula. Let's say we've got the following. Negative 5x squared plus 9x minus 2 equals 0. This is a quadratic equation in standard form, but it has a leading coefficient that is negative. So what I could do is I could either multiply or divide both sides by negative 1, and I'd get 5x squared minus 9x plus 2 equals 0. And from there, I could go on. A is 5, B is negative 9, C is 2, etc., etc. So I could multiply or divide both sides by a non-zero number to make the leading coefficient positive, okay? I'm not going to go on and solve it. I just wanted to point out that step. Here's another thing I can do. Let's say I've got 1.6 t squared plus 2.4t minus 0.9 equals 0. Well, you could use A as 1.6, B as 2.4, and C as negative 0.9, but it might be easier and a little cleaner to do if we got rid of the decimals. So we multiply both sides by 10. We get 16t squared plus 24t minus 9 equals 0. And then A would be 16, B would be 24, and C would be negative 9. And we could go from there. So we can get rid of a negative in front. We can get rid of decimals. How about fractions? Okay, let's say we've got 1/8 x squared plus 1/2 x minus 3/4 equals 0. Well, the least common denominator is 8. So if we multiply both sides by 8, 8 times 1/8 is 1. So we get 1x squared plus 8 times 1/2 is 4x minus 8 times 3/4, 24/4, or 6 equals 0. And then A is 1, B is 4, and C is negative 6. This one, if you don't clear the fractions and you use A as 1/8, B as 1/2, and C as negative 3/4, it works, but it's tricky. Most people that don't get rid of the fraction first mess up on that. So I would clear the fraction first. Fractions, I should say. All right, and finally, what about this? 33y squared plus 99y minus 66 equals 0. Well, here we could factor out a greatest common factor of 33 and then basically divide both sides by 33, so we could reduce it down to the following, and then A would be 1, B would be 3, and C would be negative 2, and we could go from there. So you can factor out a greatest common factor constant to reduce the numbers down. You can multiply through to clear fractions. You can multiply by powers of 10 to clear decimals. You can multiply or divide both sides by a negative 1 to make your leading coefficient positive. Those are all things you can do to clean up the equation before you determine the A, B, and C and plug them into the quadratic formula. Any question about any of those examples before we continue?
Yes, I do have a question on that one.
Okay.
So we divided.
Your mic, Antonia, Antonia, your microphone is distorting. I'm not sure what's going on there, but try it again a little bit slower and we'll see if we can. Go ahead.
Oh, I was saying, do we divide the 33 in between all of them? Like, oh,
yeah,
the fraction?
You could do this. I'm just using the techniques we learned in chapter 6 and taking out the greatest common factor and then dividing it out. But you could do it this way as well. Okay.
Okay. Thank you.
All right. Anything else? Nope.
No, thank you.
All right. So let's take a look at this one. X squared equals negative 5/4 x plus 3/2. All right. The first two moves, I want to clear the fractions and put the trinomial in standard form. Doesn't matter which one I do first. I'm going to go ahead and clear the fractions first. So I'll multiply both sides by the LCD, which is 4. So on the left side, I get 4x squared. On the right side, negative 5/4 x times 4 would be negative 5x, because the 4's would reduce down. And then 3/2 times 4 would be 12/2, or 6. So that's clearing the fractions. Now I'm going to come back and add 5x and subtract 6 from both sides. 4x squared plus 5x minus 6 equals 0. So now A is 4, B is 5, and C is -6. So x equals -b plus or minus the square root of b squared. B squared minus 4ac all over 2a. X equals -5 plus or minus the square root of 25. Now, -4 times 4 is -16. So we've got -16, and that's times -6, which comes out to a plus 96 all over 8. X equals -5 plus or minus the square root of, let's see, 96 plus 25 is 121 all over 8. X equals -5 plus or minus the square root of 121 is 11. So that all over 8. So I've got x is -5 plus 11 over 8, which is 6 over 8 or 3/4. X equals -5 minus 11 over 8, which is -16 over 8 or -2. So x is 3/4 and x is -2 would be the two solutions. Okay, any questions about that? All right, here comes another example. Are we good to go on? Still writing?
No, I'm good.
We're good. Antonia, you good?
Yes, I am. Thank you.
Okay. Next one. 3x squared minus 9x minus 2 equals 0. This is already in standard form. So A is 3, B is -9, C is -2. So we get x equals -b plus or minus the square root of b squared. I want to point out that the negative is inside the square there, okay, minus 4ac all over 2a. Subtracting a negative is like adding a positive. So x equals 9 plus or minus the square root of -9 times -9 is +81. Minus 4 times 3 is -12 times -2 is +24 all over 6. X equals 9 plus or minus the square root of 105. Let's see here. All over 6. Now, the square root of 105. Well, 105 is 5 times 21, which is 5 times 3 times 7, right? There's no perfect squares in there. So basically, we're done. That's as far as we can go right here. So let's get rid of that. I've got x equals 9 plus the square root of 105 over 6. X equals 9 minus the square root of 105 over 6. Going to the calculator, I still need to put parentheses around the entire numerator as well as the radicand when I put it in the calculator, that is. So let's see here, left-hand parentheses, this is to find the decimal approximation, 9 plus square root of 105, close up the radical, close up the entire numerator, divided by 6 and I get, let's see, what do I get here? 3.207, etc. The 0 would round, or the 7 would round up, so we get 3.21. That's our first answer. And then the minus, we get negative 0.207. The 7 would round up, so we'd get negative 0.21 would be our second solution. Okay. Let's see here. All right. We good to go on? Okay.
Yes.
X times x minus 27 equals 280. So here, we've got to multiply this all out, get everything over on one side to get it into standard form. So I'm going to distribute the x squared minus 27x equals 280. Then I will subtract 280 from both sides, x squared minus 27x minus 280 equals 0. So A is 1, B is negative 27, and C is negative 280. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Most of the mistakes that are made right here. People miss a sign and they have a plus instead of a minus or a minus instead of a plus. So really be careful with your arithmetic there. All right, X equals, subtracting a negative is like adding a positive, 27 plus or minus negative 27 times negative 27 is positive 729. Minus 4 times 1 would be negative 4 times negative 280 comes out to a plus 1120. All over 2 times 1 or 2. X equals 27 plus or minus the square root of, let's see here, 11, oops, you got to turn the calculator on for it to work. 1120 plus 729 is 1849. Coincidentally, that's not the year I was born. All over 2. So I think the first thing or the next thing I would do is I'd take 1849 and let's see if that is a perfect square. That would be really nice, wouldn't it? So second square root of 1849. Ha, it's 43. Sweet. So we got 27 plus or minus 43 all over 2. X equals 27 plus 43 over 2, which is 70 over 2 or 35. X equals 27 minus 43 over 2. Oh, what is that? Negative 16 over 2, which is negative 8. I think that's right. So X equals 35. X equals negative 8. So we've got those two solutions. Let's see here. Let's do this one. 2x squared plus 0.1x equals 0.04. All right. So first two moves, get it in standard form and clear the decimals. I'm going to clear the decimals first. I'm going to have to multiply by 100 in order to clear all of the decimals because of the one on the right. So I'm going to get 200x squared plus 10x equals 4. All right. Then I'm going to subtract 4 from both sides. So I'm going to have 200x squared plus 10x minus 4 equals 0. Oh, but you know what? They're all even. I could go back and I could divide everybody by a 2. You don't have to, but again, it would make numbers smaller. So we get what? 100x squared plus 5x minus 2 equals 0. So there we have it. It's in standard form. We've gotten rid of the decimals. We've reduced it by a 2. We're good to go. A is 100. B is 5. C is -2. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals -5 plus or minus the square root of 5 squared is 25 minus 4 times 100 is minus 400 times -2 would be plus what, 800 all over 200. Okay. So let's see here. We've got x equals -5 plus or minus the square root of 825 all over 200. Well, let's see if 825 is a perfect square. I don't think it is, but let's find out. So the square root of 825, no, it's not. So let's see, what can I do? Well, let's see, 825, you could take a 25 out, so you can have it 25 times, let's see, what's 825? 825 divided by 25 is 33. So this would be 25 times 33. 33 is 3 times 11, so there's no perfect squares there, but the square root of 25 is going to give me a 5 outside. So the square root of 825 becomes 5 square roots of 33. Okay, so this is going to replace that. So now I've got x equals -5 plus or minus 5 square roots of 33 all over 200. All right. Any questions so far? We're not done with this problem yet. I see that this and this and this are all, they all have 5 as a factor. So I'm going to factor a 5 out of the numerator and out of the denominator. So taking a 5 out of -5, I have a -1 left over. Taking a 5 out of 5 square roots of 33, I have the square root of 33 left over. So I got the plus or minus. So now I can reduce it down to this, and I've got x equals -1 plus or minus the square root of 33 over 40. So there's my package of my 2 solutions, but I'm going to write them separately. X equals -1 plus the square root of 33 all over 40. X equals -1 minus the square root of 33 all over 40. So again, I've got to put parentheses around the entire numerators and parentheses around the 33 inside the radical. All right. So first one, left-hand parentheses, -1 plus square root of 33, close up the radical with a right-hand parentheses, close up the whole thing with another right-hand parentheses, divided by 40, and I get 0.1186. The 8 would round up, so 0.12. So there's our first approximation. And then we'll change the plus to a minus, and we get -0.1686. The 8's going to round up, so -0.17. And there's our second approximate solution. All righty, so there you have it. Again, work on memorizing the quadratic formula. There's a wonderful song to help you memorize it. And you might want to plug your ears, but here's how it goes. It goes x equals negative b plus or minus the square root of b squared minus 4ac b squared minus 4ac all over 2a all over 2a. I know what you're thinking. You're thinking, Mr. Mayo, you better keep your day job. Your opera career is not going to take off. All right, but I am going to take off. So I'll be back this afternoon at 1:15. Should you have any questions, I'm going to go ahead and stop the recording.